So, good morning, all of you. My name is Prince Kumar, and today we are going to introduce a new video series in which we will see the PPT presentation of each and every subject that I will create for my entire academic education. Um, Currently, I am in second year, so uh, further for the next 1 or 2 years, whatever I will create in the format of PPT, I will present those all in this video series. That will be the PPT video series. Fine. So our today's topic is gradient. Uh, it is a very important topic and it is very relatable to our real life, and it mainly comes under the vector. Uh, so let's begin the today's matter. So today's topic is gradient. So what is gradient? Gradient is a vector quantity. Vector quantity means it is something like just a numeric value. Uh, it applied on a scalar quantity. Hmm? Gradient is a vector quantity, not a numeric value. It is it is applied on a scalar quantity, like a scalar quantity uh, that is only numeric format, like temperature, height, and or many different things. Uh, so concentration of dust particles can be also a scalar quantity. So when we have to calculate the concentration of the dust particles, like the slope, the increment of height, or the change of height, the change of velocity, the change of temperature, like these quantities, like vector quantities, that then we have to apply the gradient. Gradient means you can also say it is a gradually change, uh, that is called the gradient. So it can be also referred as slope. Hmm. That is same thing, gradient. So gradient of function f can be calculated by this formula. Huh. For finding the gradient uh, for any function in the question, uh, there will be a function, and by using that function we have to find the gradient value on any specific point. So it explains the variation of function in x, y, and z direction. Huh. Next. So real life example. This is the first real life example where we use the gradient. We can see the application of gradient. So we can see here gradient means the general meaning, gradual change, that is also called slope. But the really especially here we are using the gradient at as the rate of change of temperature in x, y, and z direction. Suppose you can say there is a gradient, uh, a, a, a graph uh, where this is the most heated area and this is the most coolest area. So how the this temperature is gradually changing, uh, that can we see in this graph, how the in this point, uh, this initial point, if we see there is a there is only the coolest portion, but as gradually we are increasing and this specific position, you can see also the value of heat, that is the orange line, is less than the uh, uh, coolest line. But gradually as the cooling, the graph of cooling is increasing, uh, uh, the here there is a equilibrium point, and then uh, there on a specific point the graph of most heated, uh, or the heat portion is over crossing the graph of coolest region. We can also see the real life application in our general in house or homes. Suppose if there will be a AC, it will make more or instant uh, cool or colder the nearer areas as compared to the uh, those areas who are far from the AC. So the change of temperature will be the different at different position of this house, and that can be easily see, or we can calculate by using the concept of gradient. So that's why the concept of gradient is also important in our real life. We can also see the second real life example in which we can see the different slope of this mountain for different uh, uh, with a different slope. So we can also see here the more slope, the more gradient. Less slope, less slope, less gradient. So um, the minimal slope is here, so the minimal gradient is here. The medium slope is here, so medium gradient is here. The highest slope is here, so the highest gradient is here. So we can easily here understood that the gradient is nothing but the slope. It is nothing but the uh, instant change in anything, any quantity, any scalar quantity, we can say. It is just a depiction of a direction. Gradient is what? Depiction of direction for changing or gradually changing uh, for the which quantity? Scalar quantity. So if we go through this slope, we will ride to the with the bicycle. It has less slope, so we can easily uh, climb or drive the cycle on these mountains. But here is a more slope, so it has more gradient, so it will here uh, uh, we will feel more difficulties here. So this is the real life example, but the real life question will be something like this. The question that are asked in the examination will something appears like this. So in question, how we uh, see the question, the type of the format of question. So find the function if at a point 1 2 3, this is any coordinate point in any specific area location. So for this, we have function this, and this is the general function, general formula of the gradient for finding gradient. So what we have to do, just finding for the solution, the gradient of the for these points. So simply we have to put this function at the place of this f, uh, all three places, and then we have to find the PD, partial differentiation, and then we can easily got the answer. Hmm. So I hope you all enjoyed. It is very simple for finding a partial differentiation. Just when we will put the this function here, so we will find the differentiation with the respect to x here. So if we will find the differentiation with the respect to x, then the other quantity which will come isolate in the form of in individual format, those will by differentiating will come and convert as a zero, but the quantities those will with the x variable x that will be the simply differentiated. So similarly we can find also for this function here with respect to y and respect to z, and by adding those all and by writing in the vector format, we can easily see the uh, gradient for this point. So I hope this is quite simple, and a huge thank you to all. Hmm.